Good evening, everybody, and welcome to the last talk of the day. And I'm going to talk to you about spoofing and tampering with Azure AD signing logs. And a couple of words about myself. So my name is Nestori Syynimaa. Hello. And I work as a senior principal security researcher for a company called SecureWorks. And I think most of you know me best about my toolkit called AD Internals, which it's a toolkit that you can pretty much do hacking to Azure AD and Office 365. And I'm also Microsoft MVP, or most valuable professional. Actually, I double. So I have, well, both are in same technical area, which is enterprise mobility, but I'm a MVP in both identity and access, but also in Intune. And then during the Black Hat USA, Microsoft announced a list of most valuable security researchers, and I was one of those guys, so I also hold that one. And here are my contact information if you have anything to ask after the session. And the easiest way to see or contact me, see what I'm doing and contact me is the Twitter, of course. So my Twitter handle is Dr. Azure AD, and if you don't follow me, please do so. And most of the content I usually publish can be found in my blog, 365blog.com. So please visit that too. So what are we going to cover tonight? I have a couple of things, and they are here. And without further introduction to contents, let's just deep dive in to our subject of the talk. So I'm not going to tell you tonight what is Azure AD, what is ADFS, so I'm assuming that you know what they are, and if not, no worries. There's a link you can click. I suppose I can share, well, I can share this with you, and I think that this might be downloadable somewhere later on. So yeah, so if you want to learn more about that, just click that link. So there are links to definition of things. But anyways, we are talking today about Azure AD Connect Health, and what is that? So it's a kind of, let's say, tool or service, which is meant for monitoring your on-prem infrastructure through Azure AD portal, which means that when you log into Azure AD portal, you can see that whether your on-prem services are held also. And by on-prem services, I mean services which are related to Azure AD or are connected to Azure AD, such as Azure AD Connect, which synchronizes users, and ADFS, which federates users. And how this technically works is that you need to install an agent, and that agent is installed to every on-prem service that you want to monitor, and they have to be, as I told you, Azure AD Connect or ADFS or AD Federation services. So here's the basic structure on the right side. So we have an on-prem environment here, and in that environment we have installed the agent, which is sending events to Azure or Azure AD. And as you probably know, in Azure AD, if you sign in, or if you sign into Office 365 services or Microsoft 365 services, all the sign-in activities are recorded in sign-in logs. So there are different kind of sign-in logs. There are one, well, the normal one. So if you log in using your username and password, so in other words, you are using some interactive method to sign in. Those events are stored in that log. There are also logs for non-interactive sign-in user logs, which mean situations. For instance, if you have a computer which is Azure AD joined, and you are accessing Office 365 or Azure AD with that computer, it is automatically getting you an access token without the need for you to type in your credentials. And then for service principals or applications, and then managed identity sign-in logs. And managed identity means that if you have some Azure, let's say, resource, you want to access Azure AD, you can use managed identities to do that. And then the events, the ADFS server is, the agent that is installed in the ADFS server is sending. They are stored in the log called ADFS sign-in logs. So here we are in this talk, we are interested in these two logs. So we have sign-in logs, and then we have ADFS sign-in logs. So let's just quickly see if I can show you an example of sign-in log. So here's my demo tenant I'm using today. So here we can see that if I go back here to sign-in logs, we have that user signings, interactive, non-interactive, principal sign-ins, and managed identity sign-ins. However, there is no log for ADFS sign-in logs, so they aren't anywhere here in the GUI. So how can I access them? Well, I need to go to diagnostic settings, and actually in this tenant I don't even have Azure subscriptions, so I can't show it using that one. So I luckily have another one here. So let me just browse to correct point, and I'm going to show it to you from here. So this is from another tenant. Oh, just a minute. Wrong window. That's better. So let's just widen that a bit. Okay, so here we have diagnostic settings, and here we have that ADFS sign-in logs right here. And in order to us to be able to view that, we need to send it to Log Analytics workspace. And I can show you examples. So if I go here, Log Analytics, so here actually in Log Management, and I click that open, or actually where it is it here as a Sentinel? No, actually I don't know where it is, but if I type here ADFS signing logs, say top 10 by, well, actually there isn't nothing here, but like here. So if I would have some events in this log, I could see it right here. Anyway, so that's kind of a technical background. So again, we are interested in those two logs. So here's some example, the same example I used there in Log Analytics. So I can actually list ADFS signing logs. They are here, but as I said, there's no tab here at the top for this, so I can't see only ADFS sign logs. However, for some reason, these events here, they are ingested to this user signings interactive log also. So for instance, this one here is this row, and this one here is this row, and this one here. So we can actually see also signings made against ADFS in the same log that we can see all the other interactive signing logs. So we can actually see them. So even though we have no direct access to ADFS signing logs, as I think most of at least the small and medium enterprises don't have, I mean the Azure subscription, they can still see the events here. So this is actually very good thing to those who have ADFS server and they want to see the user sign, so they can be viewed from here. Okay, so learn a little bit more technical background for this agent. So how does it work? And first of all, it consists of 3 services. So when you install that, there are 3 different services. And the middle one here, Azure AD Connect Health ADFS Insight service, is the one that is sending the the login events to the Azure or Azure AD. And it is using two background, let's say, channels. So it is using Azure Blob storage, where it's sending the actual events, and then it's using Azure Service Bus to tell Azure AD that, hey, I have just uploaded a blob of events, so do something with them. And the protocol details, how it works. So it's here. So step one is quite obvious. So user logs into ADFS server. And ADFS server, well, in order for this to work, you need to actually enable auditing in ADFS server. So now that the user has logged in, it is writing event ID 1200 to security log. I can actually show that to you. So if I go back to my server here, I can say, okay, I want to go to portal.office.com like this. Let's say, okay, that was not the correct user. So I have so many tenants, so I need to check the users using the right username. So let's use that one. Okay. And just to make things easier, I'm just gonna clear the audit log here. Yeah, now I'm signed in. And at the same time, if I go now to event log, to security log, I do the refresh, and there should be event ID 1200, which is the first one here. So if I just zoom a bit, we can see that there's event right there, and these are information that's inside that event. And we will get back to that later. Yes, so this is the same in the slides, and beside the event 1200, there are also some other events which contain information about the user. And here's that event 1200 in XML format, which is quite a little bit easier to read. And here's some interesting information. For instance, we have an IP address of the user and whether the user logged inside the on-prem network or was it outside, like through proxy. And we have the user agent user was using, the authentication protocol, and then we have things like the server name here. What else? We have a user's name here, and so this kind of information there is. So that was the second step. So first one was the user logs in. The second one was that the ADFS server is writing the event log, and the step number 3 is that the health agent is reading that information from the event log. So then step number 4, now that the agent has collected the events, it needs to send them to Azure or Azure AD. So first, the fourth step is to get a service access token. And in order to get that, you need to make a request to one of the authentication endpoints, which is there. And the body it sends there is quite, let's say, short one. So it only has a couple of information, like for instance, client secret, which is stored in ADFS server in registry. Then we have tenant ID, which is also saved there. and we have machine ID, which is also saved there. So all this information is available in the registry of the server where the agent is installed. And we also have service ID, which we need to in a second phase, but not yet. So the client secret, it's also known as agent key. So where it is stored, so it's stored in that registry value, but it's a base 64 encoded binary, and it's also encrypted. But luckily, it's encrypted with DPA API or data protection API, which means that you can actually decrypt that quite easily, as long as you know the entropy used here, and that's there. So I was able to get that out of the agent binary. So there's the agent and tenant ID, and the machine identity also can be found from the registry. Okay, so I will come back to later this. So how do we use this key? But this client secret or agent key, I mean, so the fourth step was to get the service access token or SAT. And the fifth step is to get a Blob Upload Key, which we are using to upload the events to Azure Blob. And to get this, you need that service access token or SAT. And there we have a URL where you need to post, you need to make a get HTTP GET request. And only changing thing is the service ID, which was available in registry. And when we get the key, it is actually a pre-authenticated URL you can use to send the events file to Azure Blob storage. Okay, so that's for sending the actual events, but the next step is to get event publisher key, and that is also, we also need that service access token here. And again, we have URL. The only chasing part is the service ID, which was stored in registry. And what we get back is a JSON. Well, it's just a one row JSON file, but anyway, the content type is JSON. And what we have here, we have a shared access signature or SAS token, which what we are using to notify the Azure AD that, okay, we have now uploaded the Blob, or we have uploaded the events to Blob, so please do something with them. And for that, we need this SAS token. Okay, so seventh step is to upload events to Blob storage, and the events are actually just JSON file that has information about the logged in user, about the device, and all kind of that kind of things. And here we can see, for instance, we have same information. There was an event, log event. So we have IP address, for instance. We have the user agent. What else we have? We have SID of the user. We have immutable ID of the user, UPN, and that kind of things. Of course, timestamp. So when the user logged in. So all this is now sent to Blob storage using the pre-authenticated URL we were able to get earlier. And you can have multiple events in one file, so there's no limit there. But before sending this file, it's compressed with gzip, so gzip, and you need to calculate MD5 hash, and the hash needs to be included in the request when you are sending that in one of the header files. And after you have done that, you need to send the signature to the events hub, and this is using Azure Service Bus. And before you are able to make the signature, you need to derive a key from the agent key. This is actually quite interesting. So first you calculate SHA-512 from the agent key, and that binary result is converted to hex string, and then that hex string is converted to binary by decoding that using base 64, and that was kind of making me mad. So why the heck they are doing that? But that's how they do it. And then you need to form a string to be assigned, which consists of tenant ID, service ID, machine ID. Then there's a constant ADFS-usage metrics, and then you need to have the blob URL. So where did you send that? And then date string, and when did you send that? And then you calculate signature of this, and the signature is HMAC SHA-512. And you use the derived key as the key to the signature. And then that is sent to Azure or Azure AD using the service bus. And here we can see the connection where it's taken. And as we can see, it's a WebSocket. And up here we can see a couple of different messages which are sent back and forth. And finally, the number 26 contains here. It contains the string that was to be signed, and then the actual signature. Calculate the signature, and only after we have done this, only after that, Azure AD is starting to ingesting those events to ADF assigning logs. So that's how it technically works. So how can we now exploit this? So now that we know how the protocol works, we know where to get the keys we need. So how can we exploit this? And as I told you at the beginning, I'm a creator of AD Internal Toolkit. So obviously I implemented all these things to AD internals. So with that, you can actually create the fake events. So let's show you how you can do this. So I'm back on my server, and let's. By the way, if you haven't installed the module yet, that's quite easy. So you just say install module AD internals and hit enter and answer yes to a couple of questions, and then it will be installed automatically. So it doesn't need anything more like that. Of course, you need to have rights to do that, but for instance, in your test environment, that should be quite easy. But let's say import module and AD internals. Okay, there was one extra A like this. And now we have the latest version, and this is actually quite recent version built only for this Meetup. So this is HelSec edition. And the first thing we need to do now is to get the agent information. I mean the key and the service ID and all that kind of stuff. So I can say agent info equals get AD int hybrid health service agent information. So now when I run this command, it saves the agent information to that variable. So if I say agent info dot, let's say service ID, it's there. So now I have that information. And what else I need? Well, I need to create those events, and I have a small script here, which first just creates an array of objects. Then I have set from 0 to 5, so it means that I'm going to have 5 events. But if I say, let's say 100, And we have some users here. We have some authentication types. We have authentication protocols. We have some failure types here. We have even 2 device IDs. And then I'm going to create a random ID, and I'm going to modify the date a little bit. And then I'm going to create the event and put them in array. So let's do that now. So just going to run that script. So now we have array of events here. So I said count. So what do we have? We have 0 because that's events. Yes, so we have 100 events. And the next one here is going to send those events. So the command is send hybrid health service events, and we're going to provide that agent information and the variable, and then we're going to provide those events, and then the switch, we are using the switch verbose, so it's showing us what it's doing. So here we can see that it is sending. First, it's sending the file to the blob, like here. Oh, sorry. This is the PowerShell feature. Where is put? So here we put the JSON file there, and then it's going to open the WebSocket to service bus and going to send some messages back and forth. And finally, it's going to send the notification and close all the things. And now, in let's say 15 or 20 minutes, the events will appear here. So if I go to my Azure AD tenant, go to sign-in logs, and they will appear here at some point. And we also already have some of them here. So for instance, here we can see some random IPs, and this was failure. So I actually created these events before today's session. So if I click that open, we can see that we can say, for instance, who the user was, what was the IP. We can fake the IP we want to. Well, here is no device information with this user, but I think someone has. Well, why didn't that user have any device? I don't know, because there should be device. Well, anyways, we can also fake the reason why it failed. There's some additional details. We can say that it was from extranet. I can fake the IP, the server name, and so on, and even the time. So the time doesn't have to be same. So I can adjust that a bit, like this. Some events here, they should have a little bit different time. But anyway, so now that I know the protocol, I have access to that server. I can export that key or those keys or that key information. And after I have got those, I can use them to create these fake events anywhere around the world. So only thing I need to know is the username and who I want to, sign in as, and then we have that agent information. That's it. And it's a little bit challenging because that's not logged anywhere. Of course, you can see the logs here, like for instance this, but by looking this information, I really can't tell was this a fake event or not. So there's no way for us to know is this event fake or not. And that was the spoofing part. We'll get back to that a little bit later. But before that, a couple of words about tampering. So I noticed that the event log that was sent to Azure AD when I was monitoring the traffic between the agent and Azure AD, I noticed that the JSON file it's sent there, it has the attribute called unique ID, and I noticed that that matches the unique ID. Sorry, it's not unique ID, the field name, but anyway, it matches the ID I could see in signing logs in Azure AD. So this request ID here actually matches the unique ID, which was sent to Azure AD. So I was wondering that what if I use the existing request ID as a unique ID? What happened? So let's just copy this one like this and go back here. So then I was able to do like new event, and I can provide the unique ID like this, and then all the other information I would like to, like UPN and IP address. And network type, for instance, say extranet. So when I created events like this, and then sent them to Azure AD, guess what happened? Yep. So it overwrote the existing event there. And I reported this to Microsoft, and they said, yes, we were able to reproduce that, and I was awarded $10,000 bounty for that. And they actually changed the behavior now that the request ID is always random number, so or random GUID. So it doesn't matter what I sent there, it's always random GUID. So the tampering part is not possible anymore. But it was a quite interesting finding, and this is it was not the first time when I got an idea that, hey, let's try what happens. And I think that's the quite common way that most of the vulnerabilities are found. And I was talking to Jussi after his session that that Microsoft would need to have this kind of talk also, because they are not doing this kind of sanitization checks or anything. So for instance, I have no idea why didn't they check that does this ID already exist. They just overwrote that. But anyway, that's not anymore possible. So now we know that if we have access to ADFS server, we can export the agent information, and we can fake those events if we want to. And we were able to tamper with also the logs, but that's not possible anymore. So that's fixed. However, I also noticed that if you are a global admin and you, for instance, install that ADFS health agent, that's not logged anywhere. So I was also kind of reverse engineering that process, that what happens when you register a service or agent. And I noticed that, yes, you can actually do that. So if you're a global admin, you can register fake services and agents. And after you have done that, you can spoof signing logs with those, let's say, new agent credentials. And these were not logged to Azure AD audit logs at all, which is stupid. So how does this work? Well, let's first get access token for Azure Core Management. I'm going to save it to cache like this, and then I'm going to get the username and password. Okay, so now I'm logged in as an admin of this tenant. And now if I want to create a new service, I can do that. So I can say new AD int hybrid health service. I need to give a display name for that. So I say sts3.contoso.com. So this would be the name of the ADFS service. And then this is usually same, it's just a text. So it doesn't really matter, but usually it's same than the display name. And what else? nothing else. So that should do it. So now it created a new ADFS service to Azure AD, and this doesn't actually exist. So now we're gonna add a server to this service, and we're gonna do that by register new agent, and we need to provide the service name so that it's going to right place. And then we need to give machine a name, let's say STS3, and the machine role. So we can register any kind of server or proxy we want to, well, from the supported ones. So we can say, let's say it's ADFS server 2016, okay? And I think that should do it. So now it's registering this agent, and it's also creating the certificate for that, even though that's not used anywhere, but there's a certificate involved here in this process. And it also saved all the information to this JSON file. So now I can say that agent info 3, for instance, equals get content. Oh, okay, try again. Get content and the file name there, and then we can say convert from JSON. So it's converting that to, okay, so what was wrong? Okay, there was a line change between there, so that's not good. Okay, so now it read the content of the file and then converted that from JSON to regular object. So we have, well, we can see that, so everything is here. And now we can create another events, setup events, and then I can provide the agent info 3 here, and I can send them using information of that server, that fake agent. So now, as a global admin, if I want to fill the, or if I want to poison sign-in logs using, arbitrary information, I can do that as long as I'm global admin. And now that I have the agent information, I don't need any admin rights anymore. I can do it anywhere around the world with just that information in that JSON file. So nothing else is needed. Okay. So how to detect and mitigate? So that's a fair question. So when we are exporting that agent key from an existing ADFS server, the only way you can actually detect that is to use the registry SACL, so that whenever you can define the registry key or value, well, key in this case, that whenever someone is accessing that, an event will be created in security audit log. So you can configure that. And I think later today or tomorrow, there will be some more details on that from one guy from Microsoft. I've been working with this, but I will share that in Twitter, of course, as soon as that's available. And then for spoofing, we really can detect that. So because from the Azure point of view, this is legit traffic using legit authentication and so on, so on. So you really can't detect that. At least we can detect that. I think Microsoft have some logs they can see, like different IP addresses where they are coming from, but we can't see that. Then about creating fake services and servers. Well, as I told you, they are not stored in the place that usually anything you do in Azure AD is stored. So we have audit logs here. And when I'm adding a user or if I'm configuring federation service as such. So I'm modifying domain information. It will be logged here, but those are not, and that's just stupid. I don't know why they are not logged there. But yesterday I found out that from Microsoft that they are actually logged there, however in a little bit different place. So they are logged in Azure subscription actually. So here's an example. So in this tenant I have Azure subscription, and here we can go to activity log, and here under the activity log, and this activity means for this subscription, but when I click here, there is a thing called directory activity, and this directory activity refers to that Azure AD tenant or Azure AD directory, and this is under all subscriptions you have in that tenant. So this is basically same information. So this is not subscription related. This activity is, but the directory activity is not. So this is has all the events related to that directory. It's shared by all the subscriptions. So here we can, okay, let's change that to 24 hours. And here we should have some events related to that. Okay. Let's try this way. Everything failed. Nothing interesting. But anyway, not sure why it's not showing here. Let me try again. No, they really aren't listed here. But anyway, this is the log where they would appear. So they would be like a summary, and then in JSON, if you click that, you will have all the event information. There's a lot of that information. But anyway, it will appear here. However, the challenge is that if you don't have the Azure subscription as most of just Office 365 users or organizations doesn't have, how can you access that information? That's interesting question, and using the Azure AD or Azure portal, you can't access that unless you have the Azure subscription. But yesterday I implemented a feature for that in Azure to AD internals, which allows you to do that. So like this tenant here, I use for demo. I don't have any subscriptions. So if I go here, we can see that there are no subscriptions. So I can't access that. But if I go as an admin, global admin, I go to Azure AD admin portal. I can scroll down to properties and scroll down. Here we have a setting that access management for Azure resources. So this particular admin, this is by default, it's no, because I don't have any Azure subscription. But now I want to access some features there. I can click yes, and then click save. So now this admin actually has rights to Azure, but we don't have Azure subscription, so there's no GUI for that. But when we change this to yes, we can actually get those logs using AD internals. And I implemented this new function called get AD int Azure directory activity log. And with that, you can fetch all the events that are there. And you can specify how many days, and this log goes 90 days back. So you can't get any older than 3 months old events. But anyway, so let's run this command here, because I was already logged into AD internals as an admin. I'm able to do this. So I say log events and say count. It says that we have 24 of those. Now this powerful monster here is just extracting the relevant information for us. And there's a format table, but I'm saying out grid view, so it's more Excel-like view then, like this. So it's very small there. But if we now zoom in, we can see that those top 4 lines that took place a couple of minutes ago, we can see that these are from the commands I used to create the service and to add the server. So this is the only way, as far as I know, to detect creating these kind of services. And if we look the IP addresses here, we can see that there are requests from different IP addresses, so this might look a bit suspicious. Okay, so that was that from my part. So thanks for watching, and I think it's time for questions then.
Thanks, Nestori, for a very comprehensive presentation. We do have a question from an AD noob. Can ADFS be used, for example, password spraying attack to better avoid detection, or as opposed to, for example, SMMB authentication if ADFS is available?
Yeah, I already forgot the second part, but of the question, but the first part, can you use ADFS for password spraying? Yes, you can. And before this, ADFS held agents sending those events to Azure AD, organization didn't even know that they are being password sprayed. Now they do know. Well, you can use that, but there are better ways to do that so that you don't be even detected, but that's another story.
Okay, cool. It looks like we don't have any further questions in the stream chat.
Okay.
So at this point, I'd like to say a big thank you for a great presentation and live demo. Actually, people have
Thanks for having me.
Yeah, no worries. People have been praising you in this chat, so thanks for joining us tonight. Okay, so I think we're going to have a small break before the final words from HelSec. Thank you, Nestori.